All right. So, trig functions. There are two main trig functions. There is y equals sine of x function. Okay. So, the sine function is this. Okay. The sine of 0 is 0. The sine of 45 degrees, which is called pi over 4, is 1. No, it isn't. Square root 2 over 2. The sine at pi over 2 is 1. And then at 3 pi over 4, it's square root 2 over 2. At pi, it's 0. At 5 pi over 4, it's negative square root 2 over 2. At it would be 3 pi over 2 next. It'd be negative 1. 7 pi over 4, it's negative square root 2 over 2. And then at 2 pi, we're at 0 again. And now you don't have to memorize all this, okay? But this is what the pi curve looks like. We're at pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. And if this is 1, and this is negative 1, what's square root 2 divided by 2 on your calculator once? Somebody take square root 2 divided by 2. It should be 0.7071, something around there.
0.707106.
Okay, so I was right. 0.7071. So at 0, we're 0. And then at pi over 4, we're 0.7071, somewhere right around there. Pi over 2, we're at 1. 3 pi over 4, we're there. Pi, we're at 0. 5 pi over 4, we're negative 0.7071. 3 pi over 2, it's negative 1. 7 pi over 4, we're there. We're there. This is called the sine curve. Now it keeps going like this. So if I went another 4 squares over, it'd be there. If I went back this way, it'd be there. And then it just keep going and it keep going. Okay? It's always going to be a curve like that, which is called a sinusoidal curve. Okay? So it's going to keep going up and down like that, just back and forth. Okay? Just like a wave. Okay? That's the sine function. So those of you who have never taken trig before have to kind of memorize what that kind of looks like. Okay? Who has taken trig in here? You guys. All right. So you guys kind of remember chapter 2, graphing those out. Okay? Y equals cosine of x. Instead of making the big chart, I'm just going to draw it for you really quick here. Y equals cosine of x starts at 1, 0, and then it kind of looks like this. And just like the sine curve, it keeps going on forever. And it goes on this way forever. Okay? Now, what's the difference between these two curves? What's the biggest difference you see right away of those two curves? The y-intercept, exactly. That's the thing, that's the key to this. The sine curve has a y-intercept of 0, 0. The cosine curve has a y-intercept of 1, 0. Okay? Now, Let's talk about even and odd functions. Okay? An odd function, f of negative x equals negative f of x. An even function, f of negative x equals f of x. Okay? And you're going, well, what does that mean? Well, when you put a negative number into the function, it makes the function negative. So if, let's say I'm in the sine curve, come on, I'm in the sine curve. If I go to negative pi, because at pi over 2, I'm at 1. If I go negative pi over 2, I'm at negative 1. Okay? So if I put in a negative value for this x, it makes it negative down here. So this is an odd function. Okay? A way to tell an odd function flips over both the y-axis and the x-axis. That's an odd function. An even function, what it is on the negative is the same as the positive. So at pi over 2, I'm at 0. At negative pi over 2, I'm also at 0. It's like the mirror image. At pi over 4, I'm here. At negative pi over 4, I'm here. Okay? It's the mirror image on each side. So this just flips over the y-axis. Okay? That just flips over the y-axis. Okay? So that brings us to those 12 functions. Okay? Which are even, which are odd. Okay? So what I'm going to do is I'm going to go to here and here and here and okay. There are 4 functions that are odd functions. Okay? The sine of x. What did we just say the sine of x was? Even or odd? Odd. So that's going to be one of our functions that's odd. What does y equal the square root of x look like? Okay? Oh, I tell you what. Some days my computer doesn't want to cooperate with me. Y equals the square root of x. In general, what does that look like? It looks like a curve that goes from the origin where? Up and to the right, kind of flat. Does it go to the left at all? No. It doesn't go to the left because you can't have a square root of a negative number. Okay? Would that be even or odd? Neither. It wouldn't be either even or odd because it's not a flip of anything. Okay? So we know that. There. 1 over x. Okay? What does y equal 1 over x look like? Well, that looks like this and like this. Would that be even or odd, Shanty? Because an odd function, you flip and you flip. Hey, isn't that a flip and a flip? Yeah, I think it's a flip and a flip, Shanty. So I think 1 over x is an odd function. Okay? All right. This crazy one, 1 over 1 plus e to the negative x. 1 over 1 plus e to the negative x. What does that look like? Well, it has a couple asymptotes on it. And it goes like this, and ooh, Mr. Bierschbach, that was bad. It goes like this, like this, like this. Okay? Is that an even function? No. Is that an odd function? Certainly looks like it. Because if you flip it and flip it, looks like an odd function. Just making sure it's not Mr. Ricky or somebody, Mr. Shaw or somebody important. All right, cosine of x. What do we say about the cosine of x? It's a what type of function? Even function. E to the x. Y equals e to the x. Looks like that exponential function. Is it even or odd? No. Definitely not. Okay? X cubed. What does x cubed look like? It looks like this, crosses like this, and looks like this. Is that even or odd? Yeah, that's what? Odd. You flip and you flip, it's an odd function. Okay? The absolute value of x looks like that. Is that even or odd? That's an even function. That's an even function. Okay? The integer, greatest integer function. That's that crazy one that looks like this. Zoom to there, there to there, there to there. Is that even or odd? No. No, it is not even or odd. Doesn't quite fit in those categories. All right, y equals x. Uh-oh, I think I'm in trouble here. Y equals x. Looks like that. Even or odd? That's an odd function. Flip and flip. That's an odd function. Uh-oh. What's my problem? I've got more than four odd functions, don't I? One of them's wrong. I'm thinking this one's wrong. I don't think that's odd, because if you flip and you flip, I'm not so sure. I don't think that one's odd. What's y equals x squared? Parabola, so it's an even function. And y equals the ln of x. Y equals the ln of x is a function that looks like this. It's not either even or odd. So let's check and see if Mr. Bierschbach has a brain at all. Yes, he does. Okay, so that this one is not even or odd. That one there. Okay, so you'll have some questions about even or odd. You'll ask some questions about the functions that are decreasing over the interval of negative infinity to 0. So then you just look at your functions, and you can grab a book if you need to today when you're doing this. You look at your functions, see, well, this one is decreasing from negative infinity to 0 because it's always going down from left to right until you get to 0. Then after that, you don't really care. What about this one? Is this increasing or decreasing from negative infinity to 0? Increasing. As you go from left to right, it's increasing. Okay, so we're just looking at the ones that are decreasing. Here's another one that's decreasing from negative infinity to 0, because as you go from left to right, it's going down. Okay, so you'll get a few questions like that. Now we get to piecewise functions. Hannah hates them, but guess what? They're not that bad. Okay? All right. So, piecewise functions are like two functions in one. So you might have y is equal to x plus 1 from when x is less than 0, and y is equal to 2x when x is greater than or equal to 0. Okay? So then what we're going to look at is the graph of both functions. Okay? So if you graph them out, and you can graph them on a graphing calculator, or you can graph them on paper, or you can graph them even on Desmos, which is an online graphing calculator. But if we look at these, I can only use negative numbers for this, like -1, -2, -3. -1 plus 1 is 0. -2 plus 1 is -1. -3 plus 1 is -2. So I'm at -1, 0, -2, -1, -3, -2. And at 0, I'll have an open circle at 1. It's going to look like that. That's this part of the function. Then, this part of the function, y equals 2x. So if I'm at 0, I'm at 0. If I'm at 1, I'm at 2. If I'm at 2, I'm at 4, and so on. 0, 0, 1, 2, 2, 4. It looks like that. Two functions at once. Okay. Now, you'll be asked if these functions are continuous or not. To be a continuous function, it can't have a break in it at all. What happens at 0? There's a break in there. Okay? There's a break in there. So this is not continuous. Okay? It is said to have a non-removable discontinuity, but I don't think they'll ask that today. I can't remember, but I don't think they'll ask that today. Okay? You just have to say whether it's continuous or non-continuous. Okay? Let's look at another piecewise function. Y equals -4x if x is less than 0. Y is equal to the sine of x if x is greater than or equal to 0. Let's look at those two functions. Well, actually, I'm going to do this on Desmos once, just to show you what Desmos looks like. So, if I bring up my graphing calculator here, let's go here. Let's go Desmos. Desmos calculator. So it comes up to have a screen that looks like this. Okay? So I'm going to graph y equals -4x. It makes a line like that. And then I'm going to make a second graph of y equals the sine of x. And it looks like that. Now, I had my restrictions on this where the red graph, was only from 0 on this way. So it had an open circle there. And y equals sine of x started at 0 and went like this. So this part of it you wouldn't see, and this part of it you wouldn't see. So it goes down like this, connects to there, and goes like that. Okay? Is this a continuous function? Yes or no? Yes. Because where this one would have an open circle, this one would have a filled in circle there, and it continues on. That's a piecewise function. Just two functions at once on the same graph, or 3, or 4, or 5. Depends how complicated the piecewise function is. Okay? Piecewise functions aren't that bad. Okay? And if you want to use your graphing calculator, you can. I actually, when doing piecewise functions, I prefer Desmos. And I think even in Desmos, I think there's a way to go like comma x is less than 0, less than 0. Oh, but there's, yeah, sorry, can't do something like that. So I forget how you do it, but in Desmos, there's a way to limit the domain. But if you just graph them both, you can see them right way how they look. Okay. So for the next 20 minutes, you have like 8 problems on section 1.3b. I forget how many there are. Let me look quick. There are 1, 2, 3, 4, 5, 6, 7, 8 questions. Okay. So get to work on those 8 questions, and then at about 10:30, 10:35, we'll look at section 1.4a.